It's Algebra 2, Test 15. We got through 5.7, where we're graphing quadratic inequalities, excuse me. Number one, find the equation of the axis of symmetry. Remember what the axis of symmetry is, first off? It on your plane, it's going to be that line that runs like this. So it's going to be x equals whatever that is. That's going to be the equation of it. So we're looking for whatever x is. We had two formulas that we've dealt with over the last several weeks. We found c and we found x, and both of those formulas are similar. X, though, is one we've used most recently. It's negative b over 2a. So you have to make sure this is in standard form. Ax squared plus bx plus c, it is that. It is in standard form. If for some reason it's not, move it to standard form where you can see a, b, and c easily and not make a mistake. So negative b would be negative 5 over 2 times a. 2 times a's value is 4. So negative 5 over 2 times 4 is 8. That's what x's value is, negative 5 over 8. Okay, so if we use this same graph that I already drew, negative 5 over 8 would be 5/8, would be right past 4/8 or 1/2. So right past 1/2, it would be about right there on a graph. But that x value is negative 5 over 8. The second bar tells you to find the coordinates of the vertex. So if we're graphing this quadratic, we would first find that axis of symmetry right there. Then we would find how high up or down or whatever its y value is. Y is going to be equal to 4 times, we got a new value for x. Our new value for x is negative 5 over 8 squared plus 5 times, again, that new value for x, 5 over 8 minus 1. So we have to simplify this entire problem here and square negative 5 over 8. So negative 5 squared is positive 25. 8 squared is 64. And again, these are terrible numbers, but we'll get them all straightened and cleaned up in just a second. Y equals 4 times 25 over 64 plus, we can multiply right now, 5 times 5 is 25, and 8 times 1 would be over 8. And then we have minus 1 still. So now we have to multiply one more time. 4 times 25 is 100 over 64 plus 8 plus 25 over 8 minus 1. So we got a lot of, again, still bad numbers, but we'll clean them all up now. The number that all of these go into, if you put a fraction at the bottom of this one, 1, the number that the common denominator that 64, 8, and 1 share is the number 64. So we have something that says y is equal to 100 over 64 plus, now we got to change this one. This 8 has to become 64. So we got to multiply it by 8 to get 64. So you have to multiply 25 by 8 as well. Well, we know 4 25s makes up 100, so 8 of them must make up 200. So 200 over 64 minus 1 over 1 is going to become minus 64 over 64. Again, that's the same thing as 1. So now what we have is common denominators. And again, I know these are bad numbers, but we can make it work just like this. That same number is going to stay at the bottom, 64. 100 plus 200 is 300, and 300 minus 64 is 236. So y's value is going to be 236 over 64. So 236 divided by 64 is, so just for the sake of speed, we'll call this y is equal to 3.68, which is not the best form to put this number in since we have negative 5 over 8. You almost don't want to use two separate forms, one for x and one for y. But negative 5 over 8 can easily be translated into a decimal as well. But 3.68, we knew it was going to be a little bit less than 4 because 6 goes into the number 24 4 times. So if you look at it this way, 6 going into the number 23, it's got to be a little bit less than 4. So 1, 2, 3, 4. 3.68 would be approximately a little bit above half, so it would be right there. So the rest of the directions say find the vertex of the graph. Your vertex would be these two numbers, x comma y, or your x value being negative 5 over 8, and your y value in the form we found it in, 3.68. That is a vertex. Again, they're in two different forms, those numbers, but it does represent the point that makes the vertex of that graph. And it's the fastest way to it. Number 2 tells you to graph that and label the axis of symmetry and the vertex. We got easier numbers to fool with right here. It makes it a lot easier. So what we got, again, we're looking for x's value. X is negative b over 2a. Negative b, this is ax squared plus bx plus c. That makes it nice. Negative b is negative 2 over 2 times a is 2. Negative 2 over 4 will simplify that x value to negative 1/2. So on your graph, first thing, not like that. On your graph, you're going to have something that looks at negative 1/2. So we'll put ourselves an axis of symmetry at negative 1/2. We'll put the rest of them in a second. But that's at negative 1/2. We know looking at this graph, since a's value is positive, we know it's going to open up. So we want to put our vertex, we want to put it at the bottom of our picture. And then we'll put our x-axis going across to compensate for where that point is. In order to find your y, you want to plug in negative 1/2. You want to plug in your new value for x. So in that equation, anytime you see this notation right here, f of x, that's y. Y is equal to 2 times x squared plus 2 times x minus 2. X we just found is negative 1/2. Negative 1/2. So you have to square it first. Negative 1/2 squared is negative 1/4. So 2, I'm sorry, not negative 1/4. Negative 1 times negative 1 is positive 1. So it becomes 2 times 1/4 plus 2 times negative 1/2 is going to be minus half of 2, which is 1 minus 2. So y is going to be all of this. 1/4 of 2, when you multiply straight across here, 2 times 1 is 2, and 1 times 4 is 4, which comes right back to being 1/2. So 1/2 minus 1 minus 2 is going to give us what y is. 1/2 minus 1 is negative 1/2, and negative 1/2 minus 2, y's value is going to be negative 2.5. That's going to give us our vertex. So if this is negative 3, this is negative 2, this is 1, then this right here has to be our 0. A little bit better than that. I'll stretch it from there. Again, we know it's going to open up. So from there, we want to shift our units. This is at negative 1/2, so this is positive 1. That's negative 1/2. Okay, so we want to shift to the right or to the left. Now, this question was asked yesterday. When you shift over, do you have to shift over an entire unit? Meaning, do you have to shift over to this point here, like an entire unit to go to 1/2? No is the answer to that. You just have to shift to the next x value. So we want to either shift right or we want to shift left. Remember, we could shift left and go to x equals negative 1, or we could shift right to where x's value is 0. Most of the time, we would rather use x's value is 0. So when we plug in this x value here, 0, when we plug it into the equation, y is equal to 2x squared is 2 times 0 squared. That's why we like the number 0. It's 0. Plus 2 times 0 is 0 minus 2. In that case, y is going to be negative 2. Anytime you shift over a half a unit, it's always going to be real close. So when you go over one time, it's going to be at negative 2. Again, the mirror image, the line of symmetry, tells you to mirror it right there. Now we need one more point. We could shift over to negative 2, or we could shift over to 1. X is equal to 1 is probably preferred. X is 1. So again, one more time in that equation, y is equal to 2 times 1 squared plus 2 times 1 is 2 minus 2. 1 squared is 1 times 2 is 2, plus 2 minus 2. 2 plus 2 is 4, minus 2. Y's value is going to be positive 2. So where x is 1, y's value is 1, 2, and your point is going to be right there. And again, it's mirrored where x is negative 2. Y's value is positive 2. Now you have 5 points. This is just an equation, not an inequality like the ones we've been looking at this week. So you're just going to take your lines from the vertex and draw curved lines going up through them. And that's vertex. From the vertex, that is your parabola or your quadratic. It tells you to label the axis of symmetry and the vertex. The axis of symmetry is simply x is equal to negative 1/2. That's that line right there, that axis of symmetry, the red one. X is negative 1/2. And the vertex is this point right here. Your x value is negative 1/2. Your y value was negative 2.5, which is the same thing as negative 5/2. That's your vertex. The rest of the problems get substantially quicker, not easier, quicker. Remember, graphing quadratics just takes a long time. Number 3 is an easy problem that you might have forgotten how to do. Some of y'all tried to complete the square. Some of y'all tried to do several other different things. It's all fine. We learned a few different ways to do these, but the simplest way or the quickest way is to get x by itself. That's the same thing, same steps from Algebra 1. The difference with this, though, is you have x squared. You don't deal really with undoing radicals or undoing squares in Algebra 1. You subtract your order of operations backwards, you run through. So you subtract 49 and you do it here. So you have 49x squared is equal to negative 49. Next step in your order of operations tells you to undo multiplication and division. Undo 49 times this by dividing by 49. When you do it there, do it here. Now we're dealing with substantially smaller numbers. We have x squared is equal to negative 1. So we undid addition and subtraction. We undid multiplication and division. Now we have to undo x squared. We have to undo a power. We take the square root of it, and when you do it to the left, you do it to the right. Now we got the square root of a negative value. This becomes a complex number, an imaginary number. You multiply I times the square root of 1 to get the negative out. And we know what the square root of 1 is. It's both positive and negative 1. So it's I times that. So if we clean this answer up, we'll simply have x is equal to both positive and negative I. That's the simplest way to write that answer, because you don't have to write 1 times anything. It's just both a positive I and a negative I. Okay, we could solve number 4 different ways. The easiest way to solve it, though, is to see that on the left side, this is a perfect trinomial already. You don't have to do anything to make it into a perfect trinomial. What that means is you could take the square root of this one and get x, and the square root of this one and get 6. Put this in the middle, plus, square the whole thing, and if you were to multiply x plus 6 times x plus 6, you will get back to the trinomial from before. So this is the fastest, quickest way to do this. You could have gone about this a couple of different ways, though. Instead of undoing x plus 6 at this point, you can't, because it's in parentheses. It's in the grouping symbols. We have to undo x plus 6 squared by taking the square root. So it jumps all the way to this step here. If you take the square root of that side, you have to do it to this side. That leaves you with x plus 6, the square is gone, is equal to. Now, this is a perfect square. Remember, anytime you have a perfect square, you have to represent it with 2 separate problems, both 6 and negative 6. That's why we don't have to write it twice. So undo plus 6 by subtracting it. If you subtract it from the left side, subtract it from both of the problems on the right. 6 minus 6 is 0, and negative 6 minus 6 is negative 12. This is the difference between a perfect radical and something that's not a perfect radical. Remember, when it's not a perfect radical, then you could simply just write the symbol plus or minus, and all it's going to be is the same answer at the end with plus or minus. Notice these are two very different answers, 0 and negative 12. Number 5 is a linear equation, real simple. Just simplify the right-hand side by distributing. This is Algebra 1, everybody. This times this is negative 42. You have variables on both sides, 9y plus 5 and negative 6y minus 42. When you have variables on both sides, you want to collect them on the same side. Negative 6 is smaller than positive 9, so undo that by adding 6y. If you do it here, you got to do it here. 9y plus 6y is 15y plus 5 is equal to negative 42. Undo plus 5 now by subtracting it. Again, order of operations backwards. If you do it to the left, do it to the right. These have the same sign, 42 and 5. So add them up. 42 and 5 gives you 47. And keep that common sign negative. It's not like multiplying a negative and a negative. Keep that common sign. So you have 15y is equal to that. Undo 15 times something by dividing by 15. And if you do it to the left, do it to the right. A negative divided by positive is a negative. There's no numbers that go into the number 47 that 15 shares. So it'll be negative 47 over 15. We can leave it written just like that. 4 plus 8n is equal to 28. Again, a real simple Algebra 1 question. Just 2 steps. Bring 4 over by subtracting it on both sides. 8n equals 24. Undo 8 times something by dividing by 8 on both sides. N is 3. 7 times y plus 7 equals 98. Distribute. 7 times y is 7y. 7 times 7 is 49. Equals 98. Undo plus 49 to get it y by itself by subtracting 49. Do it here. 98 minus 49 is 49 is equal to 7y. Undo 7 times something by dividing by 7 on both sides. And 49 divided by 7 is 7. Factor in these expressions. Start with number 8. 3x squared plus 7x. All you can do is factor out what each of these terms has in common. 3 doesn't go into itself and 7. It does not. The only thing they have in common is the x term. So x times what gives you 3x squared? X times 3 and x times x to get x squared. So if you multiply this times this, you would come back to 3x squared. And x times what gives you 7x? Just positive 7. Because again, if you multiplied x times 7, you would get 7x. This is the factored version, just taking out the x. Number 9 says x squared minus 14x plus 40. This is a trinomial that we could make 2 binomials out of. X times x, since our a value is 1. Now we have to look at our factors of c. 40 can be multiplied 1 and 40, 2 and 20. 3 doesn't go into it, but 4 does, times 10. 5 goes into it 8 times. 6 doesn't, and 7 doesn't. So one of those pairs will give you the number 14. 1 and 40 either give you 39 or 41. That's not the pair. 2 and 20 either give you 18 or 22. That's not the pair. 4 and 10 could give you 14. And 5 and 8 give you 3 or 13. So the only pair we can use is 4 and 10. So 4 and 10. This sign here tells us that they're the same. Remember, anytime it's positive, that means they're the same. It don't mean they're plus. It means they're the same. This one says since they're the same, that's the sign they both are. Minus 4, minus 10. Again, that can be written backwards. You could have 10 first and 4 second, but they both have to be negative. Number 10, x squared minus 7x minus 18. Same thing as number 9. Factor it out, x times x. Find your factors of c, 1 and 18, 2 and 9, and 3 and 6. You only have 3 pairs to look at this time. Which pair will get you to 7? Which pair will get you to B's value is the question. 1 and 18 is 17 or 19. 2 and 9 is 7 or 11. And 3 and 6 is 3 or 9. So you have to use 2 and 9. Now, this sign here, again, only tells you that they're the same or they're different. Since the plus one meant they're the same, minus means they're different. Since they're different, this one tells you the sign of the bigger number. The bigger number is 9, so it's going to be minus. The positive goes to the smaller number 2. X plus 2, x minus 9. Again, those numbers can be reversed. You could have 9 first and 2 second, but the negative has to go with the 9. The positive has to go with the 2. A plus BI. First thing, we can take out the negative from that radical. Remember, we know that's the number 5, but if you multiply 5 and 5, you get a positive 25. If you multiply negative 5 and negative 5, you still get a positive 25. That's why we need the imaginary number in order to take the negative out. I times the square root of 25 simply removes that negative number. So we have the square root of 25 and then times I plus 9. The square root of 25 is not the square root of 5. Remember that. Once you take it out of the radical, it is simply the number 5. But it's both positive and negative 5 times I plus 9. And again, A plus BI will be the real portion of the number first. 9 is the real portion, plus or minus 5 times I. A plus BI. 12 is completing the square. This was the other formula that looks like the one you find x with. C is B divided by 2, or half of B squared. AX squared plus BX plus C. That's the one we're looking for. B's value is 4 divided by 2 is 2 squared, which is positive 4. So C in this case is 4. Remember, when you complete the square, had it said equal to anything, which it will on the next problem, if you add 4 to one side of the equation, you have to remember to add it to the other side to balance it, like this one. X squared plus 16x plus 70. 70 is a bad C value. So what we need to do is we need to remove it and put it on the other side of the equal sign. It's positive, so you subtract 70. When you do it there, again, to balance it, you have to subtract it there. X squared plus 16x plus C is equal to negative 70. We need a new C value. In order to find C, you do just like number 12. C is B divided by 2 squared. B's value is this one here, 16 divided by 2 is 8. Squared is a positive 64. Again, just like a minute ago, when you add something to one side, like 64, you have to add it to the other side to balance it. That'll be the mistake you'll make tomorrow. Negative 70 plus 64, opposite sign, subtract them. 70 and 64 is the number 6, and 70 is the higher absolute value, so keep that negative there. So now we have something that says x squared plus 16x plus 64. This is a perfect trinomial, which means we can take the square root of the first term, x, the square root of the new c, 8, and the sign in front of the b, plus x plus 8 squared equals negative 6. And then it looks like a problem we had several problems ago. Undo, you can't undo the plus 8 first because it is inside of parentheses. So undo squared by taking the square root. If you do it to the left, do it to the right. Now you have something that says x plus 8 is equal to, we have the square root of a negative number, just like a minute ago. Take the negative out by multiplying it by I. So it's both positive and negative. I times the square root of 6. In order to get x isolated or all by itself, you subtract 8. and you subtract it on this side. Remember, you can't take 8 away from the square root of 6 because they're not like terms. So to make this say a plus bi, we'll make it say x is equal to negative 8. We'll put that one first since that's the real value, plus or minus the square root of 6 times I. And that represents two answers: the positive square root of 6i and the negative square root of 6i. Number 14 tells you to rewrite this in vertex form. Well, before you can do that, you need to start off by completing the square. This is a poor C value. It's got to go over. Subtract 32 then to move it. You subtract it there, subtract it on that side. When you do that, you have y minus 32 there is equal to x squared plus 12x plus c. We need a new c value. C is b divided by 2, 12 divided by 2, 6 squared is positive 36. Remember, when you add 36 to the right, you have to add 36 to the left to balance it. So y plus 4 is what you have, is equal to this perfect trinomial again. The square root of the first term is x. The square root of the last term is 6. The sign that's here is plus. We are almost to vertex form. The only thing we have to do to make vertex form is get y by itself by subtracting 4. If you do it there, you need to do it here. Remember, you can't subtract it from the 6 that's in parentheses because it is inside of the grouping symbol. So y is equal to x plus 6 squared minus 4. This is vertex form. And you can see the vertex. Remember, it's the opposite of what this one is, so negative 6. And it's exactly what this one is, negative 4. So negative 6, negative 4 is where your vertex would be. Number 15 says use the quadratic formula to solve the equation. Your quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac, all of that, over 2a. I'm going to have that written on the board. You have to make sure everything's in the correct spot. So this is a, this is b, this is c. The first thing you need to do is check and make sure it is in standard form, ax squared plus bx plus c. So x equals negative b, negative 9, because b's value is negative 9, plus or minus the square root of b squared, negative 9 squared, minus 4 times a is 4, times c is 8. And all of that over 2 times a is 4. Then it's simply a matter of simplifying all of this. First, simplify this discriminant part, everything inside of that radical. Negative 9 squared is positive 81. Negative 4 times 4 is negative 16. And negative 16 times 8, 6 times 8 is 48. And 8 times 1 is 8 plus 4 is 128. So we have something that says 81 minus 128. When we subtract that, 81 minus 128, they're opposite signs. So subtract 8 minus 1 is 7. And 12 minus 8 is 4. It's negative 47. So all of this is what's under the radical. So now we have something that looks like this. Negative 9 means positive 9, plus or minus the square root of negative 47 over 2 times 4 is 8. So x is equal to all of that. Remember, anytime you have a negative value in the discriminant or under the radical like this, you're going to get two imaginary answers. So the first things first, undo the fact that there's this negative here. 9 plus or minus I times the square root of 47 over 8. There's no perfect radical that goes into 47. So as bad looking as this looks, this is the most simplified answer that you can get by using the quadratic formula. 9 plus or minus I times the square root of 47 over 8. 16 says solve the equation by finding square roots. Your order of operation happens in reverse. So you undo 3 times x squared by dividing by 3. When you do it there, you need to do it here. X squared is equal to 3. Now undo x squared by taking the square root. When you do it there, do it here. X is equal to both positive and negative square root of 3. There's no perfect radical inside there. That is your simplified answer. Number 17, simplify this one by rationalizing the denominator. Remember, you can't have a radical at the bottom. So whatever that is, the square root of 2, you multiply it by it over itself. Straight across, 3 times the square root of 2 can be written just like that. 3 square root of 2 over, anytime you multiply the same radical by itself, whatever that radicand is, 2, is what comes out. If you multiply them by each other, you would have gotten the square root of 4, which comes back to the square root of 2. Then 18 tells you to multiply this one. FOIL, first, outer, inner, last. 2 times negative 6, negative 12. Outer, 2 times the square root of 5. Positive 2, square root of 5. Inner, negative square root of 5 times negative 6. Positive 6, square root of 5. And last, negative square root of 5 times positive square root of 5. Negative, same radical, 5. Combine your like terms, negative 12 and negative 5 is negative 17. 2 square root of 5 and 6 square root of 5 is positive 8 square root of 5.